What if you could give your business the gift of sight? And I don't just mean adding more cameras. I mean giving it the ability to actually understand what it's seeing. Well, that's what we're talking about today. We're diving into computer vision, a technology that's literally teaching machines to see, and it's unlocking some incredible value for businesses. So let's get right into it.
All right, I want you to start with just one number in your head. 5,000. Just let that sink in for a second. What could that possibly be?
That's right, it's 5,000 parts that need to be checked for tiny, microscopic cracks every single hour. Now, just imagine you're the person on that line. By the time you get to part number 500, your eyes are burning. By part 1,000, your mind is definitely wandering. At that point, mistakes aren't just possible, they're pretty much guaranteed. And that is what we call an impossible human task. It's a scenario where the sheer scale, the speed, and the precision needed, well, it just completely overwhelms what a person can do. It pushes way past the limits of human focus and endurance. And it's for exactly this reason that computer vision was born. So what is computer vision, really? Well, simply put, it's the tech that gives machines that gift of sight. Think of it like this. You train a digital brain on thousands, maybe millions of images until it learns to recognize patterns. It takes all that raw visual data, like a live feed from a camera, and turns it into useful information that a business can actually act on, instantly. So let's really dig into what this gift of sight means in practice. How does a machine's vision stack up against our own? And why is that difference such a game changer in a business setting? Look, a human inspector is brilliant. We are amazing at dealing with nuance, context, and stuff we've never seen before. But when you throw us at a super repetitive, high-volume job, our greatest strengths kind of become weaknesses. We get tired, we get distracted, our performance just isn't consistent. And this is where it all becomes crystal clear. Just look at this comparison. When it comes to endurance, we get tired. A machine gives you 24/7 analysis, no breaks. For scale, we're limited. A machine can chew through thousands of items an hour. And consistency? That 5,000th part gets inspected with the exact same focus as the very first one. So the big idea here isn't about replacing people. It's about boosting our abilities with machine consistency on a scale we could never dream of achieving on our own. Okay, so the theory sounds great, but where is the rubber really hitting the road? Let's look at how some of the world's biggest companies are already using this stuff to create some massive value. Let's start with Walmart. An empty shelf is more than just a lost sale, right? It's a bad customer experience, a problem in the supply chain. So what do? They use cameras that are constantly watching the shelves. The second a product gets low, the system sees that gap and automatically pings a staff member to go restock it. It's not just saving a sale, it's making the whole store run smarter. Now let's take that same idea, consistency, and apply it to something that needs extreme precision, like manufacturing. For a company like BMW, their entire brand is built on flawless quality. They have AI systems scanning parts right on the assembly line, spotting tiny imperfections that are literally invisible to our eyes. This makes sure every single component is perfect before it even thinks about going into a car. And this idea of helping human experts, not replacing them, is maybe most powerful in healthcare. Think about a radiologist. They look at hundreds of scans a day. Fatigue is a huge factor. So here, AI acts like a fantastic assistant. The system scans an X-ray or an MRI and highlights any suspicious areas for the human expert to look at more closely. It's like a second set of eyes that never gets tired, helping to speed up diagnosis and ultimately save lives. But like any really powerful technology, this is no magic bullet. For any leader thinking about this, there are some pretty significant risks you absolutely have to get your head around to do it right. So if you're looking at this tech, you've got to have 3 critical risks on your radar: bias in your data, safety and how it's used, and of course, privacy and how you roll it out. Let's just touch on each one quickly. First up is bias, and really, this is all about data quality. If the data you use to train your system isn't diverse, the system itself won't be reliable. We've seen this big time with facial recognition systems that just don't work as well for certain groups of people. From a business view, that's just an unreliable tool. It's the classic garbage in, garbage out problem, and you have to manage it. Second, safety. Now, in some situations, a mistake can be catastrophic. Think about this. A self-driving car might misclassify a stop sign, right? If a stop sign is partly blocked by a tree branch, a human driver uses context to figure it out. An AI might not. When the stakes are literally life and death, Good enough is nowhere near good enough. And finally, privacy. Using cameras to constantly monitor a workplace or a public space? That's a huge deal. It means you have to be totally transparent with everyone about how that data is being used and why. It's a serious conversation about trust and policy that has to happen long before you ever turn on a single camera.
So, knowing the incredible potential and also the serious risks, how do you actually get started? Well, it all begins with a really simple question for your own organization. You need to find your visual bottleneck.
I want you to ask yourself this question right now. Where in my business does a process slow down just because a person has to look at something over and over and over again?
The way to find it is to hunt for those repetitive checking tasks. Is someone checking ID badges at a security desk all day? Is somebody inspecting fruit for bruises on a production line? Or maybe manually counting cars in a parking lot? Then you ask the big question. Could a camera do this faster and more consistently? If the answer is yes, you've just found a perfect use case for computer vision.
So, look, this technology isn't science fiction anymore. It's here. The machines are learning to see and understand our world with incredible speed and accuracy. The only real question left for us is, what important problems are we going to teach them to solve?